I'm Jayme and I'm going to try and explain my concept map myself. I actually don't have anyone here to help me video, so hopefully I can do it myself. I'm using a iPhone, so I hope that all the terms will be clear enough and I can show you them correctly. Okay, so let's start. Here's my concept map, big picture. It's pretty big. I'm going to start up here. I just put down chemistry terms, and then from that, I kind of used the groupings that you already gave me and went to functional. From functional, I put the two branches of chemistry, organic chemistry and inorganic chemistry, and both of these branches contain elements. From elements, I put an atom because atoms are made of elements, and the mass of an atom is the atomic weight, which is expressed in Daltons. Also from an atom we have the nucleus, which is, an atom is made up of a nucleus, and the nucleus contains neutrons and protons. From protons I put determines atomic number, because that's what determines the atomic number of an atom. Also from atomic number I put isotope, and that's because an isotope has the same atomic number, but different formation. Types of isotopes, I put radioactive isotope and water isotope. So basically an isotope will have the same number of protons, which determines atomic number, but a different neutron number. So those are two different types of isotopes, is a radioactive isotope and a water isotope. Also I put the half-life of an isotope, which is the time it takes for an isotope to return to its normal number. Okay, up here, from nucleus of an atom, I have electron, and that's because an electron spins around a nucleus. From electron, I have electrons are found in electron shells, and the outer shell that spins around the nucleus contains valence electrons. So valence electrons are found in the outer shell. Okay, back up to electron. In a redox reaction or oxidation reduction reaction, electrons are transferred. That's part of the reaction. And then also the loss or gain of an electron determines an ionic or an electric charge, which determines an ion. So here's an ion, and the positive ion is a cation, and the negative ion is an anion. Two types of cations are hydronium ion and hydrogen ion. I kind of use hydronium ion here to explain acid and base, because for a base reduces the number of hydronium ions, and a acid, which I have all the way up here, releases hydronium ions. So here we go, here's the acid link. It's kind of way up there. Okay, so let me go back to atom. Atoms combine to form molecules. Two or more elements equals a compound. Molecules are found in compounds. Okay. From molecules, I have the terms cohesion and adhesion, and that's because cohesion, the definition of that is it causes two or more molecules to stick together, and adhesion is two unlike molecules. Two or more unlike molecules. The mass of a molecule isn't the molecular weight, but is relative to the mole, because without the molecular weight you couldn't determine mole, which is 6.0 times 10 to the 23rd, I'm correct, which is Avogadro's number. From molecular weight I have measured in Dalton, so that's what it's measured in, and molarity determines the mole too. Back up here to molecules, I have isomer over here, because an isomer has the same molecular formula, so I kind of just attached it to molecules, but it has a different spatial arrangement. Also over here up on compound I have two types. I have salt and water. There's a few branches off from water. I have hydrophobic interaction. That's because in a hydrophobic interaction does not dissolve in water. I have water dissociates in acid, and an acid is measured by its pH balance. So right there, I have that. And also I have two water molecules form a hydrogen bond, which is a network of water. Okay. We go back to molecules. Molecules form chemical bonds. Types of chemical bonds are ionic bond, and in an ionic bond, it either gains or loses valence electrons. So I have that attached right there. Also in an ionic bond, electronegativity helps to form the bond. Another type of bond is a covalent bond, and I have a covalent bond shares valence electrons during its process, and some different types of covalent bonds that I have listed are double covalent bond, triple covalent bond, non-polar covalent bond, and polar covalent bond. Okay, I also have non-covalent bond, and a type of that is a hydrogen bond. All right. So let me go back up to, that's all the functional terms that I think I did. Let me go back up to functional. I can go right over to elements, and to elements I connected the critical, I have types right here because these are critical elements to life. Potassium, calcium, iron, chloride, nitrogen, hydrogen, sulfur, carbon, sodium, oxygen, and phosphorus. I also connected polymers up here to compounds because polymers are compounds. And I had a hard time configuring this because a lot of them have the same, polymers in them, but I tried to do the best I could. I have nucleic acids right here, and then I have nucleosides and nucleotides because that's what they contain, and then I have proteins right here, carbohydrates, and carbohydrates contain sugars. Sugars can be monosaccharides or disaccharides or polysaccharides, so I have that over here, but they can't, that's what sugars can be. And then I have lipids, glycolipids, phospholipids, fatty acids, glycerol, and saturated fats. These two come off from fatty acids because those are the different types of fatty acids. Back up here, here's element, functional. For functional groups, I put include, and then I have hydroxyl, and that contains alcohol, but it also can ketone and aldehyde. Also, I have carbonyl, and that's kind of a big group, and that contains ketone and aldehyde as well. Carboxyl contains carboxylic acid. Then we have down here amine and amino acid. So amine contains amino acid and methyl. And then sulfohydryl as well. And that's it for functional groups. And then off to the left here from chemistry terms, I have include relevant units of measurement. These are different types. Gram is a basic functional unit for metric system for weight. Then we have a meter, then the liter, and the milliliter. And the liter is a functional unit for volume, and milliliter is the liter basically divided by 1,000. So a thousandth of a liter would be the actual definition of that. And I think that's it. So let me show you my map from far away. It's pretty big. And there we go. Thank you, and I'm Jayme Edwards, and I am in your introductory cell biology lab. Okay, thank you.